Now, in pretty much every kitchen, there's a roll of this stuff. Seems so simple, right? Disposable, almost boring. But the story behind this thin, crinkly sheet of aluminum foil is honestly one of the most epic industrial tales on the entire planet.
Seriously, have you ever actually stopped and thought about it? We tear it off, use it, and toss it without a second thought. But getting it to that point involves one of the most intense, high-energy manufacturing processes we've ever invented.
So, we're going to go on a little journey here. It starts deep inside the Earth's crust, moves through fiery chemical reactions, and involves harnessing just unbelievable amounts of electrical and mechanical power. All of that just to make the very thing you wrap your leftovers in.
So, where does our story begin? Not with shiny metal. Nope. It actually starts with a kind of reddish-brown dirt. This is the very first step, turning raw earth into a super refined powder.
It all starts with a rock called bauxite. Now, this isn't some super rare mineral, but it only really forms in specific tropical climates. Think places like Australia or Guinea. It's where millions of years of intense weather have basically washed everything else away, leaving these aluminum-rich minerals concentrated right near the surface. So miners can just scoop it up in these huge open-pit mines.
So how do you get pure aluminum out of this dirt? Well, first, they crush the bauxite and give it a bath in a hot, really caustic solution. This dissolves the aluminum stuff, but everything else, all the iron and silica, sinks to the bottom. This creates a toxic sludge they call red mud, which, by the way, is a huge environmental problem to deal with. What's left is a liquid that they cool down to form crystals. Then they bake those crystals in a giant kiln at 1,000 degrees Celsius until all that's left is this pure, fine white powder, alumina.
All right, so we've managed to turn red dirt into white powder. But turning that powder into actual metal, that requires an almost unbelievable amount of raw power. This next step is, by far, the most energy-hungry part of the whole process.
This whole thing relies on a process figured out way back in the 1800s called the Hall-Héroult process. Basically, you dissolve that alumina powder in another molten chemical and then, wham, you zap it with a massive electrical current. And that jolt of electricity is what literally rips the aluminum atoms away from the oxygen atoms they're bonded to.
And when I say massive, I am not kidding. We're talking about currents of over 300,000 amps running constantly. To put that into perspective, the amount of energy it takes to make just a few pounds of new aluminum could power your house for weeks. This is exactly why aluminum smelters are almost always built right next to massive power sources, like huge hydroelectric dams. They need that constant, cheap juice.
So, we did it. We have pure, molten aluminum. The next challenge is totally different. It's one of brute mechanical force. How in the world do you turn a giant solid block of metal into a sheet that's thinner than a piece of paper?
Well, first, they pour the liquid metal into these enormous slabs called ingots. Then, they heat them up until they're soft and malleable and start feeding them into a series of rolling mills. Just imagine these giant polished steel rolling pins squeezing the ingot over and over and over again, making it longer and thinner with every single pass. And all of that rolling leads us to one of the biggest kitchen mysteries out there. You've all noticed it, right? One side is super bright and shiny, and the other is kind of matte and dull. Is there a reason for that? Oh yeah, and the answer is just some clever engineering. See, for that very last super thin pass, the foil is so fragile that it would just tear if it went through the rollers by itself. So what do? They double it up. They actually roll two sheets at the same time, stacked on top of each other. The shiny sides are the parts that touch those perfectly polished steel rollers, and the dull sides, those are the sides that were pressed up against each other. And no, for cooking, it makes absolutely zero difference which side you use. Total myth.
Now, we mostly think of foil for wrapping last night's pizza, but its unique properties make it an absolutely critical and often totally invisible material in dozens of industries.
See, the thing about aluminum foil is that it's an almost perfect barrier. Light, moisture, oxygen, germs, pretty much nothing gets through. And that's why it's in everything, from the wrapper on a chocolate bar to those aseptic milk and juice cartons to the blister packs that keep medicine safe. It's used as insulation in buildings and even on spacecraft to control temperature. It's in your car, it's in your phone, it is literally everywhere. But let's be real. This incredible journey from dirt to foil comes at a huge environmental cost, mainly because of all that electricity we talked about. Luckily, aluminum has a secret weapon, a kind of superpower.
Just look at the difference here. This says it all.
Making new aluminum from that bauxite ore is one of the most energy-intensive things we do as a species. But recycling existing aluminum, the energy required just plummets. It's not just better, it's ridiculously efficient.
Get this, recycling aluminum saves a staggering 95% of the energy needed to make it from scratch. 95%. It's an almost perfect loop. The material can be melted down and reformed endlessly, forever, without ever losing its quality.
Now, it's not totally perfect. There are a few challenges. For us at home, the foil needs to be relatively clean of food gunk. And here's a pro tip. You should ball it up into a decent-sized lump, say bigger than a golf ball. That way, it won't fall through the cracks in the sorting machinery. The bigger problem, though, is composite materials, where foil is stuck to plastic or paper. Those are much harder to separate and recycle.
Okay, so we've gone on this massive global journey. From a mine on the other side of the world, through a smelter, a rolling mill, and into your kitchen drawer. What's the main takeaway from all this?
I think it's this. The simplest, most ordinary things often have the most extraordinary stories. That thin, disposable sheet is the end point of a colossal industrial chain that involves geology, advanced chemistry, and forces we can barely even comprehend.
And that really brings us to the most important point. Aluminum's true potential, its sustainability, is only unlocked if we actually complete the cycle. The material itself is a modern marvel, but its true value is only realized when we treat it not as disposable trash, but as a permanent resource.
So I'll just leave you with this thought. The next time you pull out that roll of foil, are you going to see it differently? Will you just see a wrapper, or will you see the whole story? The story of a material that truly touches almost every single part of our modern lives.